The National Weather Service officially determined a deadly
tornado that tore across the southeastern part of
North Dakota over the summer
was indeed an EF5 tornado.
And this was upgraded this morning.
On October 6th, 2025, the National Weather Service released a report that ended the longest EF5 tornado drought in the United States. The violent Enderlin tornado, which struck on June 20th, 2025, was upgraded from an EF4 to an EF5 after mathematical analyses confirmed that its strongest winds exceeded 210 miles per hour. But how exactly did this tornado, which initially seemed like a common summer EF3 twister, work its way up to becoming an EF4 and lastly, a history-making EF5? And how is it related to another June 20th tornado that served as the foundation for the enhanced Fujita scale as we know it today? Watch closely, as we could very well be entering an era where EF5s are no longer going to be once-in-a-decade storms. June 20th, 2025. Storm chasers across the United States drove their way up to North Dakota. After forecast models in the area hinted that storms with significant tornado potential could develop within the day. The meteorological setup across the northern plains was very favorable for extreme severe weather and supercell formation. The convective available potential energy, or CAPE, measured at over 3,000 to 4,000 joules per kilogram, which meant that the atmosphere was perfectly unstable for strong updrafts and storm growth. On top of that, dew points in the mid-60s to 70s provided plenty of moisture. There was a highly sheared environment favoring rotating storms, and the lift from the shortwave trough made way for intense storm initiation and updraft development. On paper, everything looked promising. However, early in the day up until late afternoon, some chasers felt like it might be another chase bust, with the sky showing little to no storm development in the target areas, including near Jamestown. But as nighttime crawled in, the atmosphere turned volatile. By 8 p.m. CDT, the Storm Prediction Center issued a moderate risk of severe thunderstorms across parts of North Dakota and Minnesota. A 10% hatched tornado risk was placed over the mentioned states, paired with a 45% risk for damaging thunderstorm winds and a 30% risk of large hail across the same region. Less than an hour later, this massive EF3 tornado touched down right in front of the chasers, who hadn't given up despite driving around until clear skies that morning.
We got a strong tornado on the ground behind us, just outside of Jamestown. Strong inflow.
This would later be known as the EF3 Spiritwood tornado, which went on to severely damage a home, toss several vehicles, and obliterate small outbuildings. Luckily, despite its monstrous yet beautifully structured size and shape, this tornado didn't cause any injuries or fatalities. Upon recording this tornado's full track, some chasers in North Dakota likely called it a day. But those who were really up for the adventure of a lifetime continued pressing toward the next developing storm, even when the nighttime darkness left them with little to no visibility of how the skies surrounding them were beginning to churn. These adrenaline seekers and researchers wouldn't be disappointed, because although they didn't know it at the time, or even for several months afterward, they were able to witness the birth of the first EF5 tornado in 12 long years, which is probably one of the most defining badges of honor that any tornado chaser could ever dream of. June 20th, 2025, 11:02 p.m. The tornado that would soon become the Enderlin EF5 tornado touched down in Ransom County, just south of Enderlin City. It started off weak, snapping trees at EF0 intensity. But as it moved east-northeastward, crossing County Road 55 and inching into the open fields, it widened and intensified. It destroyed an outbuilding, continued to snap large trees, and just before crossing the Elbow Lake subdivision rail line, it accelerated its widening and intensification. Moments later, the tornado struck a stationary CPKC freight train, derailing 33 cars in an event that would later become the centerpiece of the Twister's historic EF5 classification. The train consisted of 19 fully loaded grain hopper cars, each weighing about 286,000 pounds, and 4 empty tanker cars, which weighed roughly 72,000 pounds each. As the tornado struck, 4 of these freight cars, which were composed of 1 filled grain car and 3 empty tankers, were completely derailed and pulled into the rail's adjacent field. Another empty tanker car was tossed 600 to 1,000 feet away from the track. The sheer weight of these rail cars alone was enough to convince any meteorologist that this was an exceptionally violent tornado. However, due to a common complication with the enhanced Fujita scale, which will be explained later, these train cars, despite being the most striking evidence of the tornado's power, were not initially taken into account during the rating process. More focus was given to the damage that the tornado caused during the remainder of its life as it turned north-northeastward. Here, evidence of EF3 strength became most prominent, with the tornado blowing over an anchored cell tower, snapping and debarking large trees, and leveling an unoccupied farmhouse. Minutes after impacting the train, the tornado narrowed but maintained a violent EF4 intensity as it approached ND46. One tree was thrown nearly a quarter of a mile from where it originally stood, with its root ball still attached. Then, an entire forest along the Maple River was leveled, with only stubs remaining. Many of the trees in the area showed signs of a phenomenon known as sandpapering, where once the bark was stripped away, the wood's surface was left unnaturally smooth, as though it had been polished by hand. This rare phenomenon only occurs when a tornado is strong enough to hurl dirt, debris, and gravel so forcefully against the trunks that they almost act as natural sandpaper. As the tornado crossed the North Dakota highway, it obliterated 2 homes, killing 2 people. Then, it proceeded to level a second house and a wide swath of trees as it crossed the Maple River.
This is all that's left, nothing left of 2 homes in this area. Tornado went through just before midnight.
We got a report of a residence just to the east of us that had lost its roof, so our deputies responded to that area to go check on those individuals. When they got to that, those individuals were shaken up from their roof being blown off. The residence just to the east of them, that house was gone, and that they believed that the individuals there were deceased. So our deputies then went over to that one and learned that there were two adult individuals deceased, 1 female and 1 male.
The tornado turned north, gradually weakening to EF2 strength, and only inflicted roof damage to a mobile home. However, it didn't take long for it to re-intensify to an EF3, which made it powerful enough to level the farmhouse where the 3rd and final casualty occurred. The tornado began to lose strength as it turned northwestward, but still managed to topple several steel transmission towers. And, in its final stretch of fury, it looped back south near the Utke waterfowl production area and dissipated 5 miles southwest of Alice at 11:21 p.m. During its 19-minute lifetime, the Enderlin tornado's track only covered 12.1 miles, making it the EF5 tornado with the shortest recorded path length in history. But as you know by now, this tornado wasn't even rated in EF4 at first, let alone in EF5. The enhanced Fujita scale, which is the most up-to-date system for classifying tornado intensity in modern meteorology, is essentially a damage-based scale. It features 28 types of standard damage indicators, or structures that can be commonly found across the United States, ranging from family residences, mobile homes, and high-rise buildings to farm-out buildings. Depending on the degree of damage seen to these indicators after a tornado's passage, surveyors and experts can then determine how strong the winds must have been to inflict such damage at a given site. Now, during the preliminary survey conducted by the local National Weather Service days after the tornado, the storm was initially rated an EF3. But as with all preliminary assessments, this rating was published with a disclaimer stating that it was subject to change pending further evaluation. As expected, in the months that followed, the National Weather Service re-examined key damage points along the Enderlin tornado's path to verify or reclassify its preliminary EF3 rating. During this second evaluation process, they identified multiple signs of at least EF4 level intensity, including the severe debarking of entire forested areas, the uprooting and displacement of trees with intact root balls, and the swept clean foundations of several farmsteads. During this reanalysis, nearly all standard damage indicators were carefully reviewed, but there was a problem, one that's commonly encountered when surveying violent tornadoes in rural areas or open fields. The fact that there was simply no available damage indicators to conclusively prove that this tornado had EF5 intensity, even if it had in fact occurred. There were no well-built homes or engineered structures that, if destroyed to a sufficient extent, could have definitively shown that the winds exceeded 200 miles per hour, beyond the EF4 threshold of 166 to 200 miles per hour. Eventually, researchers had to confront the elephant in the room. There was no standard damage indicator that could prove winds of EF5 intensity. However, there was a non-standard indicator that could take on this role. The 33 derailed train cars, whose grain loads weighed up to 286,000 pounds per car, and whose empty tanker car was found more than 600 feet from the track. Because of this, the National Weather Service coordinated with forensic wind engineering experts to use non-standard mathematical modeling to determine just how strong the winds had to be if they were powerful enough to overturn and hurl this freight train. With the help of Tim Marshall, Jim Ledoux, Dr. Connell Miller, Dr. Greg Kopp, Dr. David Sills, and the entire Northern Tornadoes Project at Western University's Canadian Severe Storms Laboratory, an in-depth engineering analysis was conducted over several weeks to determine whether the Enderlin tornado's winds truly exceeded EF4 intensity. These experts utilized the findings and mathematical framework from a peer-reviewed forensic analysis developed and published by Dr. Connell Miller in the Monthly Weather Review in 2024. The study's goal was to develop a forensic tool using analytical tornado models to estimate lofting wind speeds based on trajectories of large compact objects, as the enhanced Fujita scale does not consider the wind-induced movement of these objects. And for the first time, this forensic modeling approach delivered what it promised. Applying Dr. Miller's trajectory models, researchers calculated that overturning a fully loaded grain car of such size and weight would have required winds nearly 230 miles per hour. And to hurl an empty tanker weighing 72,000 pounds between 600 and 1,000 feet away, the tornado's winds would have to exceed 266 miles per hour. These findings closely match the extreme wind velocities detected by the KMVX radar at the same time the train was derailed, serving as another layer of confirmation that the tornado's strength was indeed deserving of an EF5 rating. So, in an extraordinarily rare decision, the National Weather Service accepted these scientific findings and officially upgraded the Enderlin tornado from an EF4 to an EF5.
This morning, the National Weather Service office in Grand Forks, North Dakota reported that they are upgrading a tornado from this summer to an EF5. To be classified as an EF5, wind speeds have to be greater than 200 miles per hour. The National Weather Service says the June tornado near Enderlin had max winds greater than 210 miles per hour.
estimating that its wind speeds were well over 210 miles per hour. Upgrading a tornado rating despite the absence of standard damage indicators that would normally be required to prove any twister's intensity is pretty much unheard of. In fact, this is only the second time the National Weather Service has upgraded a tornado's rating based on non-standard damage indicators. The first was the 2011 El Reno Piedmont tornado, which was also uniquely rated an EF5 despite there being no EF5-worthy standard damage indicators in the immediate damage path. Dr. Miller's forensic framework, which utilizes real-world object trajectory modeling of large compact objects, could now open the door to a new era of tornado assessment. After all, scientists can now evaluate future tornadoes, and even reevaluate older tornadoes based on the motion of large, heavy objects like freight trains, instead of exclusively relying on the buildings and structures they destroy. Considering this, it wouldn't be a stretch to say that officially rated EF5 tornadoes could be more common in the future. The confirmation of the first EF5 tornado in 12 years, dropping on a random Monday in October, was undoubtedly something that took most people in the weather and storm-chasing community by surprise. The drought of EF5s has always been a hot topic within meteorological circles.
This is a extraordinarily sad situation in Joplin. People are just looking for their loved ones. They're looking for family members. If you take a look here at this neighborhood.
We haven't seen another EF5 tornado since these storms more than 10 years ago.
But it does have tornado experts wondering why, because this is the longest stretch without an EF5 in recorded history.
Could there actually have been more EF5s in the past 12 years?
There have been many more tornadoes which could have caused EF4 or 5 damage.
There were plenty of theories about what caused the drought, and over the past few years, bold claims that perhaps we would never see another EF5 again even circled around. So, unsurprisingly, many weather enthusiasts theorized that if this drought were to end, it would be broken by a monstrous, horrific twister that would wreak catastrophic destruction. Not by an older tornado that was initially rated as an underwhelming EF3. However, if we take a step back and look at the bigger picture of this event, the Enderlin tornado, which struck on June 20th, 2025 in North Dakota, was perhaps the most symbolic way the EF5 drought could have been broken. That's because, exactly 68 years prior to this event, on June 20th, 1957, the first F5 tornado to ever be documented in such remarkable detail that it had a full visual and analytical reconstruction of its life cycle also touched down in North Dakota. The Fargo F5 tornado. This was the very storm that made Dr. Tetsuya Ted Fujita, the man who would later create the original Fujita scale and lay the foundation for the enhanced Fujita scale, go from an almost unknown researcher from Japan to one of the most influential figures in modern severe weather research in the United States.
In case of future tornadoes, what people should do, that's the kind of thing we want to find out.
His 67-page research paper, which presented an unprecedentedly detailed analysis of the Fargo tornado, cemented the idea that tornadoes could, in fact, be forecasted and studied with such precision. It contained over 180 photographs of the Fargo tornado, outlined its meteorological setup, included detailed maps of tornado paths, had a complete visual reconstruction of the tornado's life cycle, and even included a cartoon-like animation that depicted how the Fargo tornado evolved through each stage. The Fargo F5 tornado, which ripped through North Dakota on June 20th, 1957, became Dr. Fujita's critical stepping stone to eventually proving that the damage left by a tornado could be the key to revealing its true wind speeds. And exactly 68 years later, on that same date, the Enderlin EF5 tornado pushed the enhanced Fujita scale even further, as it paved the way for a method that can reliably estimate wind speeds despite the absence of the traditional damage indicators. What's your opinion about this coincidence? Let us know in the comments below.